Okay, so today we're going to be looking at finding the standard deviation of a list and a table of grouped data, grouped continuous data. So this screenshot over here was taken from a GCSE stats paper. You're given this formula for a standard deviation, or you get given this alternative formula for a standard deviation. I prefer the alternative formula, so that's what we're going to be using throughout this video. There's one more formula for a standard deviation, and that is when you have continuous data. So that is your sum of fx squared divided by the sum of f minus the sum of fx divided by the sum of f squared, and then the square root that. So basically, let's break down what we actually have. So this x just represents variables. So if you have numbers in a list, x, 1, 2, 3, this symbol here, sigma, basically means a sum. So add. So if I have my x, let's find my x squared variables. 1 squared is 1, 2 squared is 4, 3 squared is 9. So your sigma x squared is basically summing up your x squared values. Your n refers to your number of terms in x. So basically, I've written out 1, 2, 3. There's 1, 2, 3 terms. So n would be 4. If I added another number, so n would be 3, because there's 3 numbers. If I added another 2 numbers, maybe 7 and 11, I now have 1, 2, 3, 4, 5 terms. So your number of terms, n, will be 5. So n is basically just how many numbers are in the list. And then similar here, sigma, sum of your x values. So that's basically adding up your 1 plus 2 plus 3. And then of course you're now 7 plus 11. And then your n here still means number of terms. What the standard deviation basically does is it tells you how much variation there is of each value away from the mean. So if you have a low standard deviation, your numbers will be pretty clustered and very close to the mean. If you have a high standard deviation, it probably means you're going to have a bunch of outliers and none of the values are too close to the mean, if that makes any sense. Now, the way we write standard deviation is we use this lowercase sigma, which looks a bit like an O in a line. And then down here, this little box here, you write the variable. In this case, our variable is in terms of x, so you can write sigma x. That is the same thing of saying standard deviation. Standard deviation of x. However, if I had sigma y, that means my variable is y. So that would read as the standard deviation of y. If I square my sigma, this is known as the variance, which is basically just a squared version of the standard deviation. But the thing is about squaring it, you're going to be dealing with the variable x squared, whereas all your list is going to be in terms of x. That is why we square root it. So we have a unit that is based on the variable you were given to begin with, if that makes sense. Don't worry too much about it. Let's have a look at how we would use our standard deviations in some practice questions. So remember our formula for our standard deviation. Sigma x is the sum of x squared over n minus the sum of x over n squared. What this basically is your mean of the squares and you should know this from GCSE maths. The sum of x over n is just adding up all your values and dividing by how many values there are. So this is just your mean squared. So what you're basically doing is you're doing the mean of the squares minus the square of the mean and then square rooting it. So this question, pretty much just simple substitution. We've got the sum of x squared, 3000, divided by the n, which is 20, so there must be 20 terms in whatever list there is. And then we're minusing the mean, which is 240 over 20 squared, and we're taking the square root of that. So now you just go to your calculator and you write this. So 3000 over 20 minus 240 over 20 squared. And you get a standard deviation of 2.449 to 3 decimal places. That's pretty much it. Bit of substitution. So now let's look at a harder version. So now we have the weight in kilograms of 5 babies. So we've got 2.69 kilograms, 3.44 kilograms, 4.52 kilograms, 3.47, 3.20. Okay, weight. So I'm going to call this variable x so I can use my standard deviation formula, which is sigma x is your mean of the squares minus your square of the mean, and you square root. So what I might start by doing is writing out what I know. So let's work out the sum of x, which is just adding up your x values. So we've got 2.69 plus 3.44 plus 4.52 plus 3.47 plus 3.20. Because this is a calculator course, you can use your calculator and just add up all of these. And that gives us 17.32. So we know our sum of x. N, how many terms do we have? Well, we know it's the weight of 5 babies. But if you didn't read that, you can just go 1, 2, 3, 4, 5. There are 5 terms. Now, what is our sum of x squared? So that's basically you square all of these and add them together. So 2.69 squared plus 3.44 squared plus 4.52 squared plus 3.47 squared plus 3.20 squared. So you go to your calculator and you just square all these numbers. And that gets us 61.781. So now I'm able to do the calculation. So our sigma x, or standard deviation of x, is our sum of x squared, which we figured out was 61.781, divided by the number of terms n, which is 5, minus, and then the mean, which is your sum of x, which is 17.32, divided by number of terms in the list, 5, squared, and we take the square root of that. So 61.781 over 5 minus 17.32 over 5 squared, and that gets us 0.597. What did they want it to? 3 significant figures. To 3 significant figures. In fact, let's give them units, kilograms. And this seems like a fairly low standard deviation, so maybe the numbers are quite like close to our mean value. Okay, another question. And it is summarized the statistics for us. So this is like the first example. So the number of errors, and it gives us the variable x, of each 25 pages of a magazine were recorded. Here are the summarized results. Calculate the standard deviation for the number of errors. So first of all, we know our formula for the standard deviation of x is your mean of the squares minus your mean squared, and you take the square root. And we know n is 25 because it says here it's about 25 pages. So your standard deviation is just a bit of substitution. Your sum of x squared, that's the wrong number. Your sum of x squared, which is 6840, divided by 25, minus your mean, which is 195, divided by 25 squared, and you take the square root. So again, it's very simple. You just type it into your calculator. So 195 over 25 squared. And that gets us 14.6 water units errors. Okay. So now let's look at our final example. Calculate an estimate for the mean. You should know your mean, which you can write as x bar from GCSE maths, is your sum of x over n. But when you have continuous data, it's the sum of fx divided by the sum of f. Luckily, it's given us the sum of fx, which is your frequency times your midpoints for each x variable. So, and now we just need to divide it by the sum of f, which is your sum of your frequency. And it's already told us your sum of frequency is 50 people. But if not, you could have just added all of these and then figured out it was 50. So your mean will be your 1855 divided by 50. So if I do that, 1855 divided by 50, that gets us 37.1 minutes. Now, calculate an estimate for the standard deviation. This is where you need to use your continuous version of the formula, which is your sum of fx squared divided by the sum of f minus the sum of fx over the sum of f squared. This is still the mean of your squares minus your mean squared. So mean of the squares minus the square of the mean. So now we need to add a new column to this table, which is your fx squared. Remember, it's f times x squared, not f x squared. So your f times your x squared, which we're going to write as fx squared. So what you need for your x is you want to find the midpoint for continuous data. So from 0 to 30, we've got 15. From 30 to 40, we've got 35. And then we've got 40 to 60, we've got 50. 60 to 100 is 120. That is not right. 60 to 100 is 80. My bad. Being a bit daft. And remember, we're doing f times x squared. So 25 times 35 squared times 50 squared times 80 squared, which will give us our fx column, fx squared column. So that's 2,700. 25 times 35 squared is 30,625. 8 times 50 squared is 20,000. And 5 times 80 squared is 32,000. So now I'm going to add up my fx squared. So I'm going to write here my sum of fx squared. And that is just adding these numbers together. So 2700 plus 30625 plus 20,000. I'm going to do it again. I think I might have made a mistake. 2700 plus 30625 plus 20,000 plus 32,000. And we have 8,5,3,2,5. So now I'm going to find my standard deviation by doing my sum of fx squared, which was your 85325, divided by your sum of f, and we already know your sum of f from earlier is 50, minus your mean, which is your 1855 over 50 squared, and we want the square root of that. So typing that into your calculator, you get 18.2 minutes to one decimal place. If I've made any calculation errors, let me know in the comments, but that is how you find your standard deviation in all cases.